Okay, so when we're given these type of problems, this one starts with a constant deceleration of 40. What does that mean? Deceleration. It's an acceleration that's just negative, right? So what I can start with here is I can say the acceleration is negative 40. Okay, so I've used that part. It says it produces skid marks measuring 160 feet before coming to a stop, so we're definitely going to be using that at some point. How fast was the car traveling when the brakes were first applied? So it just seems like this is all we have, but it's not really the case. What would I do to get the velocity based off the acceleration? Take antiderivative, right? So if I take the antiderivative of negative 40, what do I get? Negative 40t plus some constant, right? What this constant is, and you can put plus c, that's fine. I'm going to put plus v naught because that's what you would see in like a physics type problem. What v naught is it's your initial velocity. Whenever you see that little like 0 down there, that's just the initial. So I don't know, like integrated math and I think Algebra 2, you saw things like this. That was just like your initial height, okay? Okay, so we have an initial velocity here. So that would actually be for this problem. And you might just want to write this because you're going to have to do these problems on your own. So V naught is the car's speed. When the brakes were first applied. Okay, that's your initial velocity. That's a velocity when you actually step on those brakes. Now, do we know what that velocity is? Does it tell me up here? No. Okay, some problems it'll tell you what that is and maybe leave off another part of the problem. So we don't know what that is, but that might be, a piece that we're looking for. When does the car stop? When the velocity is what? 0. So that's something that isn't really written, but you should know. So let's maybe write that here. The car stops. Whoops. Can't spell. When the velocity is equal to 0. So let's set this velocity equal to 0 and find the time when the car stops. We can't find the exact time, but we can find it in terms of this. So let's find when v of t is equal to 0. And if we solve that for t, what would I get? V naught over 40. Right, you'd subtract this over and then divide by the negatives, so the negatives will cancel. Okay, so this is the time when the car stops. Okay, and then if we want to go back one more step, because do you see how this is in feet here? If we're talking about feet, is that going to deal with the acceleration, the velocity, or the position? Position. So I need to get back to the position function to actually use this part of it. So let's go back one more step. Position, like I said, the book uses S of t. If you want to use something else, it's not a big deal, but I'll just stick with that. What would be the antiderivative of the negative 40t? Negative 20t squared. And the antiderivative of this would be what? V naught t. And then we would have our initial position. How far has the car went from when we first applied the brakes right at the beginning? The initial position would actually be like 0, wouldn't it? We didn't actually move anywhere. So here we can really cross this off. And let's just write the constant. here is 0 because we haven't traveled anywhere at the beginning, right? Our S of 0 is 0. If you plug 0 in here and 0 in for your t, wouldn't you get 0 for your constant in the back? Okay, so that one we can kind of ignore. Now, I'm going to give you guys a minute to kind of think about what we can plug in to try to actually solve this from what we have. Remember, we have this piece here. We're going to use that. And we have this 160. This is how long it takes for the car to stop, right? How far has the car traveled when it stops? 160 feet. So our position is 160 when our time is this, right? So that's what we're going to do is we're going to plug in the 160 for our position. And then we're going to plug this in for our time. That's how much time it took for it to stop. So instead of t squared, we have this squared. And be careful you square the top and square the bottom. Does that look right to everybody? And then what we're trying to solve for, how fast was it traveling when the brakes were first applied? This is actually what we're trying to find, isn't it? What that initial velocity was, how fast it was going. So go ahead and try to solve this for V naught. If you want to replace it with x's or something, if that little, 0 confuses you, or get rid of the little 0, that's not a big deal there. So I just kind of did that first step here, and this is 20 over 1600. This you'd have to multiply by 40, so this is 40 over 1600. If you add those together, we would get, and I'm not reducing it yet, but you obviously can. So that's what I have, equals the 160. And then to get rid of this, you can either divide by that or you can multiply by the reciprocal. I'm going to get rid of a 0 here, and then 2 goes into 160 80 times, right? So really we have 1/80th V naught squared, so you'd multiply both sides by 80. So if I multiply this side by 80 and this side by 80, that'll cancel that. Just in case you had to do stuff without your calculator here. And then you can take your 16 times your 8 and get that 128, and then add a 0 and add another 0. And I'm not going to have you try to square root that without your calculator. But you could just write square root of that and it would actually be accurate. So. Okay, so do we get an initial velocity of approximately 113? Somewhere around there? What would it be correct to 3 decimal spots? I don't have my calculator. 0.137. And then what would be the label on that? Feet per second, right? It was how fast when they were first applied. So this would be in our feet per second. Could we get a negative for a velocity? Velocity can be negative, but speed has to be positive, right? So if you do get a negative, it just means that the car is like going backwards or going to the left, or, it just depends on the physics problem. But velocity technically can be negative. If it asks for the speed, though, what would you do with your negative values? You just take the absolute value of it, right? So, questions on that at all? I don't think you would get a negative typically in these type of problems, but. Okay, so a lot of these problems are like ones we did yesterday. I think the back couple are like this one here, so you guys have some time to work there then.